Okay, it seems we are live now. Hello, guys. My name is Milan, and I'm here to say a few words while Peo is arriving to this talk. He's probably finishing currently, but I wanted to remind you again to use the chat window from the right-hand side to ask questions to Kevin and to engage with our virtual booths after this presentation, of course. So Peo is here. Peo, Kevin, the stage is yours. Thank you.
Thank you,
Good luck.
Milan. Well, hello here in the mainstream of the financial services um, sessions. Well, today, I feel like a teenage boy who can exercise air guitar in his bedroom and dream to be on the stage one day with his idols. And what do you see? I'm opening for Kevin Tyson, who is not only one of the smartest people in the industry, but he is extremely kind. And what I treasure most with him is his extreme patience with me, particularly, and his willingness always to share his knowledge. This is the tremendous gift of being close to Kevin. So I wouldn't waste any more time, and I'll ask him to start because it's always interesting and it's.
Thank you very much, Peo. Can you hear me okay? We did sound check before? Good. I am going to be presenting an experience report basically on 3 of the knowledge graphs that I have worked on. These knowledge graphs were, the goal of none of them was to be a complete capital markets knowledge graph, but they provide crucial foundations for one if one were to build it. The first we're going to talk about will be a commercial effort that I participated in, and hence I'm going to have to be a little vague about names and things like that in order to comply with my non-disclosure agreements. And the other 2 are part of open standards organizations, and we can get into excruciating levels of detail there. Let's see if we got the thing working here. Yes. So I'll give you a little background. I'll describe each of the knowledge graph efforts, and then the conclusions of what we learned from them. As you can see from the picture, I have been around the block a couple of times. When I started on Wall Street, computers were 16-bit and they came in refrigerator-sized boxes. This was back in the day when the software that we were building moved trillions of dollars, but $1 trillion was still $1 trillion. So I kind of fulfill Edgar Dijkstra's definition of a subject matter expert. I've made most of the mistakes one can in software development, enterprise architecture, and information architecture. I've worked on a number of open standards. I served on the architecture board with the OMG, where I chaired the semantics working group. And this was so long ago that semantics had actually nothing to do with what we think of today in terms of the semantic web. We were focused on being able to precisely specify the semantics of operations described at interfaces. We wanted to be able to make formal specifications of operational semantics of what would happen if you invoked something at an IDL interface. We did a lot of research, but we were never able to get it to be adopted as part of either UML, the MOF, or IDL. Currently, or most recently, I have contributed to both FIBO and the ISO 20022 standardization efforts. So our first knowledge graph effort. This was a legal knowledge graph for a big player in capital markets and money center banking. It's a U.S. bank, but it operates in over 100 external markets. Like everybody who wants to stay in business when you're regulated by the controller of the currency, they have policies and procedure manuals that contain the constraints on the business operations. And they are committed, strongly committed, to be in compliance with all the applicable laws and regulations all of the time in all of the jurisdictions in which they compete. And they put a tremendous amount of effort into this, and they are largely very successful. As I mentioned before, in order to keep the controller of the currency off your back, if you're a bank, then you are going to be maintaining catalogs of your business capabilities, software assets, hardware assets, human assets, data descriptions, et cetera, so that you can demonstrate that you're doing a satisfactory job of data governance. The goals of this effort were manifold. Initially, the big problem we had was this. We have all these laws and regulations, and we have our policies and procedure manual. How do we relate the two? What do lawyers have to put into the policies and procedures manual so that they can point at a specific law or regulation? Given how long we've had lawyers, and we've had them a lot longer than we've had programmers, you would think that this would be a fairly trivial thing. It turns out this is one of the things that lawyers do to help burnish their image as public servants. It turns out that in different courts, they use different standards. And there are different standard organizations, they're actually businesses, that publish these standards on a yearly basis. What this creates is, kind of madness when you move from jurisdiction to jurisdiction. The next goal was to have machine readable copies of all the laws and regulations applicable to the markets in which the bank competes. There are a number of challenges to this immediately. This is when we're in the United States, these laws and regulations are going to be written in English. In other countries, they may not be written in English. And even where they provide an English translation, it may not be considered authoritative. And of course, the goal was to be able to trace from changes in these external laws and regulations to the affected parts of the policies and procedures. This was the basic functionality we needed to deliver. And on top of that, we adopted a couple of stretch goals. We wanted traceability from changes in the policy and procedure to the impacted software and hardware systems and the operations of those systems, so that when something changed, everybody could be lined up to respond to the change appropriately. The other thing that we wanted was a vocabulary of topics harvested from the laws and regulations. We realized that we had by having digitized the laws and regulations, we had a tremendous resource that could be utilized for NLP to come up with definitions, well, better definitions, and to actually discover what things were in the law. This effort faced a number of challenges. As I mentioned, there is a lack of standardization in legal references. The scale of the digitizing effort, this is literally hundreds of different jurisdictions around the world. And if you consider that in the United States, we have both national and statewide regional regulations, this is a tremendous pile of text. The technology for harvesting topics was still fairly new when we got started, and getting our feet wet with it and getting it adopted was a challenge. One of the things that really surprised us was the intellectual property issues we encountered with some of the public information sources. And I'll go into greater detail about that later. But this is something that we encounter in the open standards world that isn't spoken about much. But to face these challenges, we brought a couple of advantages to the table. We had very, very strong support from the top of the firm. Our product sponsor would meet with us once a month. And to give you an idea of what I mean by top of the firm, sometimes they couldn't attend the meeting because they had to field the call from Christine Lagarde or Janet Yellen or some other lightweight like that. But they also stood our product up in front of the legal department and said, you will collaborate to make this work. And that really was, in terms of my experience as a software developer, brand new. The business users were actually incentivized to collaborate with us and share their knowledge, and this helped immensely. And one of the other things that helped was that the people doing the knowledge graph had no legal expertise at all. Oftentimes, if you're working in capital markets or any financial environment, you'll get a bunch of developers who, based on having a credit card, a car loan, and maybe a mortgage, are willing to mansplain to the business management what an interest rate derivative is. Because we embraced our ignorance, this made the lawyers even more willing to collaborate with us. What was the outcome? We succeeded in meeting the goals, the basic goals, and the stretch goals. tools, and the tool that we produced was integrated into the chosen commercial practice management product. It was a short-lived effort and only lasted a couple of years, and the goal was not for us to take over the total software requirements that they had in order to support the lawyers. So it was very successful in that regard. The lessons that we learned were manifold. The natural language processing and text engineering were crucial to our success. We used, for the text engineering side, a tool from the University of Sheffield called GATE, General Architecture for Text Engineering. It is quite mature, quite robust in its core functionality, and provides a tremendous variety of plugins that you can use. In order to store the data, and in order to maintain the data that we extracted as a result of the NLP and text engineering, we used a property graph to manage both the digitized documents and the word embeddings that we used for similarity searches. Integration of the property graph into our RDF graph, we used GraphDB, was much less difficult than we anticipated, and this was before the most recent round of federation tools that Ontotext has delivered. The intellectual property issues surprised us. Because this is capital markets, because it's financial services, and we're working in RDF and OWL, we immediately went to FIBO, and because I had worked with FIBO in the past. And we wanted to use that as the jumping off point for a lot of the concepts that we had. We sat down with the lawyers to review it and discovered that there was reuse of proprietary information in the FIBO model. They would quote, as opposed to link to, Investopedia, who has a term of service which prohibits derivative products. And it's interesting because if you're familiar with something like the Bloomberg, if you search on a Bloomberg, they will give you search results from Investopedia because they're doing a web-wide search, but in their internal data, they are very, very careful to make sure that there are no intellectual property issues when it comes to the descriptions of the data elements that appear. And the other thing that we found is, it's better to find meaning in the relevant text than to have software developers invent it from whole cloth. In our case, we were able to vet the topics that we found with the lawyers, again, rather than having to rely on our the birdbath-like depth of our knowledge to make do. The second and third knowledge graph effort that I'll be describing is part of ISO TC68 SC9 work WG1, which is the Technical Committee 68 Financial Services, Subcommittee 9 Information Exchange for Financial Services, and Working Group 1 ISO 20022 Semantic Models. For those of you who might not be familiar with 20022, it's a multi-part international standard that describes a common platform for the development of messages. It comes with a modeling methodology, a data dictionary of business terms that are relevant to all kinds of financial communications. It mainly is dealing with payments and security transactions. And it also contains message definitions for affecting these messages. The other partner in this effort is the Financial Fix, the Fix protocol. And it's a language that is used extensively in, I think most extensively in the equities trading, but also in fixed income. And it likewise has a message schema and business concepts. Both of these two standards, produce XML schema and XML documents when you use them, but the technology that is used to maintain them as standards is different. ISO 20022 uses eCore, and Fix has a product that they developed years ago which serves them very, very well. One of the things this creates, though, is kind of the silo environments that we regularly wrestle with in financial services. So for our initial take at this, the goal was to produce semantic web representations of the business and conceptual model of 20022, and you do the same for the fixed models as well. We then wanted to be able to provide semantic integration in the form of predicates, relations that would link elements in the two different graphs, and we would use the qualified relations pattern in order to be able to annotate these relations so that we could have additional semantics. This was, of course, before RDS star and Sparkle star, which makes that much easier to do now. But the qualified relations pattern is good in that it's not a low-level technology solution to the problem. It actually forces you to think more about the architecture of the information that you're venting out. Here are the challenges that we faced. As I mentioned, the two protocols use different tools to manage their models, and they are published by actual organizations that have very distinct registry management processes and don't share models between them. One of the things that was kind of disappointing was, unlike my experience of working on the legal knowledge graph, neither the 20022 or the fixed models contain sufficient textual annotations to make the same kind of NLP tooling very useful. And it wasn't just, and this problem persists to today. Anytime that you're using similarity tools, such as the similarity indices built into GraphDB, this is one of the challenges that you face. For instance, we recently performed a little experiment in which we took FIBO and the GLEAF ontology, the Global Legal Entity Identifier Foundation's ontology, ran the similarity indices against them. And while FIBO has a tremendous amount of textual annotations, it's the work that Alyssa Kendall has done in managing their metadata has been superb. On the GLEAF side, there weren't quite as many. And so this didn't produce the kind of matching scores that we wanted to see. The other point is that this effort predates data.world, and hence, we really, really struggled. We're volunteers doing this as side jobs, and we were trying to stand up, the requisite hardware and software in order to make the interlinking of concepts between these different models, available to the public, and we just were not able to pull that part off. So as I said, we came away with tools that allow us to produce RDF-OWL representations of the models and the messages. We've demonstrated that Shackle can be used to create the sort of closed world constraints that you find in XML-based message schemas, and that data modelers and data engineers are quite familiar with. And we've demonstrated the ability to transform messages between the two protocols. But this is very low-level stuff. Where we're dealing here with the messages that are flying back and forth, not the big concepts that something like FIBO is trying to solve. Which brings us up to the current version of this effort. What we're trying to do is employ the latest version of ISO 11179, which is the metadata registries standard, to create metadata registries conformant with it for 20022 and Fix. So the goals of 11179, which is right now in the process of being published in its new form, is to standardize the description of data, come up with the common structures that can be used for running a registration process and a registry, and manage the components that make up the description of data, and to promote reuse wherever possible. We want to use these registries to create a spectrum, to support a spectrum of annotations. We want to be able to run, NLP and reasoning tools to provide ground facts for upper level ontologies for capital markets or financial services. So in order to do this, we need to be able to support more than just description logics. We need to be able to link the concepts in these models to external documents so that we don't have to cut and paste text from external sources in order to be able to make NLP work. And the other goal is, once we have all of this in RDF and OWL, is provide a common semantic web-based technology approach to actually managing registry operations. As you can see, I'm a big standards guy, and this slide is completely conformant with the World Health Organization standards for eye strain. And what it's trying to show you is here in the lower part, where we have the existing registries and the registrars, we want to transform those into the MDR catalogs that you see on the right. And we want to be able to query those and apply additional semantics against them. Where the additional semantics is going to come from is the bluish box on the left. This is the heterogeneous tool set. It is an EU project. And what they've done is put together a number of logic languages and provers for those languages that allow you to do more than just description logic. We can do full first order logic. We have higher order logic. And it is possible, and this, of course, isn't the only extension that we want to do. We also want to be able to provide shackle assertions. And we want to be able to provide text annotations, things similar to RDFSC also, or SCOS related. We want to be able to provide these in a graph that's distinct from the graphs that we use for the MDR catalogs and for managing the registration process, so that the folks in the world who are participating in the use of these standards can propose things like, shackle constraints. One of the things this will allow is users of the standard to be able to take a copy of the registry and apply the same technology to their data dictionaries, so that they can achieve better integration with their existing software and anything that is described in 20.022 and FIX. So some of the challenges that we're facing. We're going to have to get the registration authorities to be willing to adopt a 11179 based semantic web tooling foundation. Another challenge that we face is there's the top quadrant EDG product, which fulfills some of the functionality depicted in the previous slide. They are a very strong supporter of open standards and open source, and they were much of the driving effort behind Shackle, but the part of the specification where the part of their product where they do crosswalks, which allows you to do many of the functionality, same things that we've proposed here, including discovery via the use of NLP, isn't part of an open source tool that they use. It's core to their value proposition. Another challenge is description logics itself. It's not for the faint of heart, and first order logic and higher order logic are even more so. This is not going to be a selling point for hardcore agile developers that just want to write Java, or millionaire accountant CIOs for whom the logic isn't directly applicable. But this is an important thing for us to be able to sell, because this is where the discovery of our middle or upper level capital markets ontology is going to come from. We need to be able to provide secure access so that the registration management group operations are secure, while at the same time providing transparent and open access to the user community, people who are using these standards to actually exchange, valuable messages, and researchers who want to do things like, develop something like FIBO. Data.world may well be the answer. That still remains to be explored. And then the big question is there a customer for a capital markets ontology? Right now, on a daily basis, both 20022 and FIX are used to, transmit messages with total values of trillions of dollars on a daily basis. If we look at FIBO, which has benefited from years of the best ontology and software engineering talent that I know, we're still at $0 trillion a day in terms of its used to actually move money around the market. I don't think this is a defect on the part of how FIBO has been built or the people who have been building it. I think it's a matter of the market incentives in which we're trying to compete here. And this will face also any effort that we make to try and just do this catalog-based approach to a foundation. So in conclusion, one of the things that makes the work we do here in financial services unique is that our whole domain is this information-centric social construct. And it's been this way for thousands of years. The oldest piece of human writing that we can actually read is in the British Museum, and it's a tax ledger from Assyria. We've been doing financial services and providing information technology support for it for thousands of years. We're highly regulated across the globe. And these regulations provide the definitions of things that keep the market participants out of jail. I think it's probably a pretty good idea to use these definitions as the basis for all of the modeling that we do, so that we will be helpful to people who are looking to stay out of jail. The other thing that I've learned from all of these experiences is that we should stop pretending that software development is the most complex task in human history, and that if we can therefore unleash agile software developers on any problem and have them explain the business to the business. This is real. I mean, this is to the point where at the end of our first project, I made the joke that I'm going to change the joke that we're all familiar with, what do you call 500 lawyers at the bottom of the ocean a good start? It's only a good start if each one of them is handcuffed to an agile developer. This specification that we're producing is going to be published as an ISO technical report next year. When it's going to be published, I'm not sure, because the ISO process is kind of, is complicated, takes time. But sometime next year we will have this up, and all of the software that we develop to illustrate what we're trying to produce in the technical report will also be open sourced. And with that, we have come to the end of my presentation.
Thank you very much, Kevin. It's a great presentation. Thank you indeed. It has been really, really interesting. I have learned details which I was not totally aware previously. My question, when we are going to be able to play with this, is already answered by you, that sometimes next year, I guess for a small fee. And we have like a minute and a half for a small question. I believe Alex was interesting to know how you interacted with the text analytics gate tool, how the graph and the text analytics interacted.
What we would do is produce RDF from the gate tool and then simply import it into GraphDB.
And Dennis Wisnowski asked, do you have an alternative for the third bullet on your last slide? Yeah, this was the radical proposal.
Yeah. The alternative is being information focused instead of software focused. We live in a world where, and this won't change anytime soon, supposedly working code carries the day. And the question is, what does working mean? A simple, for instance, when we first found the first effort that we did, one of the scariest moments of my life was when we did the demo to our sponsor, and she turned around to her direct reports and said, "This is exactly what I want on everybody's desk next quarter."
It's a blessing.
Right.
You never expected. Okay.
Right. So I
Good.
think it's going to require a change in how, we need to become more data engineers than software engineers.
Thank you, Kevin. This is an excellent conclusion. So thank you very much again for your presentation. Let's switch to the next one.